Very good morning to 100% here. Today we'll discuss about the topic initial value and the boundary value problems. Okay. So the initial, first of all, you have to know what is meant by initial value problems. Okay. So see this sum. The problem of a y dash, y double dash plus 2y dash that is equal to e power x. Okay. They are giving the two subsidiary conditions. Okay. So the two subsidiary conditions y of pi is equal to 1, y dash of pi is equal to 2. Okay. So see this x value here, initial boundary condition x value is given as pi. Okay. And see this subsidiary condition, the y dash of x. Here also the x value is given as pi. Okay. The two boundary conditions, okay, we are giving that same value. Okay, same x is equal to pi, and here the subsidiary equation x equal to pi, and here also x equal to pi. Okay, that type, in this case we are considering this is the initial value problems. Okay, so we go for the boundary value problems. Y double dash plus 2y dash that is equal to e power x. Okay, this is the given problem. Okay, for this problem we are giving the two boundary conditions. One is y of 0 equal to 1, another one boundary condition is y of 1 equal to 1. Okay, so see here x is value is 0. Okay, and see this boundary condition x value is equal to 1. Okay, so the x limit is in between 0 to 1. This is the x. Okay, the limit is 0 to 1. Okay, so the value is in between. We have to find out the value in between the 0 to 1. Okay, so we have to find a solution for in between the 0 to 1. Okay, that type of problem is considered as the boundary value problems. Okay, so the x value is between the 0 to 1. Okay, so next we discuss the problem, the initial value problems. Okay, so find the solution of the initial value problems, and here find the solution of the initial value problems. Y dash plus y is equal to 0, y of, and they are giving the boundary condition. Only they are giving the only one boundary condition, y of 3 is equal to 2. Okay, and see this is the y dash. Y dash is nothing but dy by dx, and y is nothing but, that is, keep it as a y. Okay, so y double dash is nothing but, we have to double time integrate, double time differentiate of this equation. Okay, that is d square y by dx square. Okay, so see here the given problem is y dash plus y is equal to 0. You have to find out the solution for this problem. Okay, and we are given only one boundary condition, that is y of 3 is equal to 2. Okay, here the x value is 3 and y value is 2. Okay, so now we have to frame the auxiliary equation. How we have to frame the auxiliary equation means we have to keep it as y is equal to 1 and y dash equal to lambda. Okay, and y double dash equal to lambda square. Okay, so here the lambda is equal to, see here y dash. Okay, we have to substitute that y dash equal to pi, and y is equal to 1. Okay, so therefore this equation we rewrite like this: lambda plus 1 that is equal to 0. Okay, so here therefore the lambda is equal to minus 1. Okay, that is m1, that is real function, is equal to minus 1. Okay, so when the lambda is equal to minus 1 means, okay, we have to write the complementary function for this. Okay, that is y of x equal to c1 e power minus h. Why you are putting this minus h? Because of this minus 1. The real function is we get the minus 1. That's why we are write the complementary function like this: y of x equal to c1 e power minus h. Okay, so you have to apply the boundary condition in the equation, that is y of 3. Okay, boundary condition. What is our boundary condition is, see here y of 3 is equal to 2. Okay, that is nothing but, when we have to substitute the h equal to is 3. Okay, okay, so you have to you have to substitute that h equal to 3 in this equation. Okay, so therefore h equal to y of 3 is equal to c1 e power minus 3. Therefore y of 3 value is given here. Y of 3 value is here. Y of 3 is value is 2. Okay, we have to substitute the 2 here, and c1 e power minus 3. Okay, and this is that then finally the c1 value is 2 into e power, this e come here means 2 by e power minus 3. So you 2 by e power minus 3 we replace like this, 2 into e power 3. Okay, so by substituting this equation in the our boundary conditions. Okay, what the boundary condition to complementary functions we are writing. This is the complementary functions. Okay, so therefore y of x equal to the c1 value is 2 e power 3. Okay, so these values are right here. Okay, 2 e power 3, and the next one is e power minus x. Okay, that's why I have to write the e power minus x. Okay, so this is that initial value problem. So we have to see the another one initial value problem. So okay, so you see here they are given the equation like this: d square y by dx square plus dy by dx minus 2y is equal to 0. You have to find the solution for this initial problems. Okay, and the boundary condition we are giving this: y of 0 is equal to 2 and y dash of 0 equal to 5. Okay, they are giving the two subsidiary boundary conditions. Okay, subsidiary, there is y of 0 equal to 2, the x value is given as 0. Okay, and here also see the x value is given as the 0. Okay, so they are giving only the initial conditions for the both the subsidiary. Okay, that's why the problem is called the initial value problems. Okay, so we have to replace that given, we have to write the auxiliary function for the given equation. Okay, so our auxiliary function for the given equation is lambda square y by dx square is you have to take as a lambda square plus dy by dx you have to take this, that is y dash, that is you keep it as a lambda, and minus 2, y is what is y is equal to 1, therefore 2 into 1 minus 2. Okay, and that is equal to 0. Okay, so this is the auxiliary function for the given problem. Okay, so we have to rewrite this equation minus 2. Okay, so we have to factorize this minus 2. Okay, and find out the two real functions. Okay, so when you have to multiply these two functions you have to get the minus 2. When you have to add these two functions you have to get the value of 1. Okay, so this is the condition for the factorization. Okay, so see here, minus 1 into 2 minus 2. Okay, this value is getting, and you have to add this value minus 1 plus 2, you have to get the value of 1 here. Okay, so we have to this two factorization. Okay, you have to choose here. Okay, so you have to rewrite this equation: lambda minus 1 lambda plus 2, that is equal to 0. Okay, therefore you have to split that to equation. Lambda is equal to 1. Okay, lambda minus 1 equal to 0, then lambda plus 2 equal to 0. Therefore lambda 1 is equal to 1, the lambda is 2 equal to minus 2. Okay, so this is the two m1 and m2. Okay, so see this complementary functions. Okay, so this is the complementary functions, and okay, so that is complementary functions. m1 is not equal to m2, that is real and not equal. M is equal to m1. Okay, m1 is equal to m2, that is real and equal. And imaginary functions. Okay, this is the imaginary functions. Okay, the image for the imaginary function, the complementary function is e power alpha x into I c1 cos beta x plus c2 sin beta x. Okay, so we are getting the complementary function like this only. Okay, so that is lambda 1 is equal to 1 and lambda equal to minus 2. These two conditions are real and not equal. Okay, for the real and not equal we have to choose, we have to apply this complementary function. Okay, so c1 into e power m1x plus c2 into e power m2x. Okay, so this is that complementary functions we are choosing. Okay, okay, so instead of c1 you have to put the a, and instead of c2 you have to put like the b. Okay, so a e into alpha 1x plus b into e into alpha lambda 2x. Okay, that is m1x and m2x. Okay, so therefore lambda 1 is equal to 1, lambda 2 is equal to minus 2, you have to apply here. Okay, therefore y of x equal to a into e power lambda 1 x is nothing but 1 and lambda 2 is minus 2. Okay, you have to substitute here. Therefore then another boundary condition is y dash of 0. Okay, so you have to differentiate this equation. Okay, so y dash of 0, so you have to differentiate this equation e power x, that x will comes here. Okay, so that is a instead 1. Okay, is come here 1 into a into e power x minus 2x here, you have to substitute here. Okay, minus 2 into b into e power minus 2x. Okay, Now you have to apply the boundary conditions. So boundary condition y of in the equations 4 and 5, okay, y of 2. So now see this, you have to apply the boundary condition y of 0 is equal to 2, and that is x equal to 0 and y is equal to 2, okay. Now you have to apply the boundary conditions in this equation, okay, in the equation 4, okay. So let's see here, y of where is instead of x you have to substitute 0, okay. So e of a into e of x plus b into e of 0, okay, substitute the value here. That is y of 0 is equal to 2, okay, you have to substitute here, and a e power 0 is 1 and b e power 0 is 1, okay. So the final a value is a plus b is equal to 2, okay. Now you have to apply the second boundary conditions in the second complementary functions, okay, that is equation 5, okay. So that is a into e power. So second boundary condition is y of 0 is equal to 5, okay, that is x equal to 0 and y is equal to 5, okay. So you have to apply the value where instead of x you have to substitute the value 0, okay. Therefore a into e power 0 minus 2 into b into e power 0, okay. So e power 0 value is 1, so finally y of 0 is value is 5, okay, that's you have to put the 5 as a minus 2 into b, okay. So now you have to solve this two equation, that is a plus b is equal to 2, a minus 2b is equal to 5, okay. Therefore substitute these two equations, finally you can get the value to, that is two complementary functions, that is a two unknowns, a value and b value, okay. So the a value is 3 and b value is minus 1, okay. Now you have to substitute this unknown value into the your complementary functions, okay. That is, what is your complementary functions for this equation is, this is the complementary functions, okay. We have to assume, okay, these complementary functions based upon your factorization, okay, m1 and m2 value, okay. The m1 value is 1 and m2 value is minus 2, that is a real and unequal, okay. That's why you are choosing this complementary functions, y of x equal to a into e power lambda 1x plus b into e power lambda 2x, okay. Now we have to substitute this a value and b value here, okay. Therefore the a value is 3 and b value is minus 1. Substitute this here, y of x equal to 3 into e power x minus e into minus 2 power x, okay. This is the final solution for the given problems, okay. So